then we define matrix division to go with matrix multiplication. Well, the answer to that is a hard no. Let's think of multiplication and division of real numbers, however. For example, 5 divided by 7. You could think of that as 1/7 times 5. That is, you could think of division as multiplication. We do sometimes have a concept of matrix multiplication that simulates matrix division. Let's start with a reminder. I is the identity matrix, and I acts like the real number 1 in the sense that multiplying a matrix by I does not change the matrix. Now, back up here, dividing by 7, or multiplying by 1/7, what's the relationship between these numbers? Well, 7 times 1/7 equals 1. Bearing in mind that the identity matrix acts like 1, we define the following. Let A be a square matrix. So A is n by n. There might, or then again, there might not exist another matrix B such that A times B equals B times A equals the identity matrix I. We call such a B the inverse of A, as in multiplicative inverse, and write it as an A with a -1 symbol in the upper right. If this matrix exists, A is called non-singular. if this matrix does not exist, A is called singular. Most matrices are non-singular. That is to say that A inverse usually exists. However, when I say that, I mean it in a kind of formalized mathematical sense, that if you created a matrix completely at random, it would almost certainly have an inverse. Since the matrices we look at in the real world are not created completely at random, we do see singular matrices show up in application.